Good morning, my dear students. In this video presentation, as usual, we'll discuss some more problems meant for class 12 of CBSE. The first problem goes like this. Solve sin 3x cos 3y into dy minus sin 3y cos 3x dx is equal to 0. This is the question given to you. It comes under variable separable method. If we are able to separate the variables and integrate and then get the solution, it's called variable separable method. Let me just see how we go about it. Sin 3x cos 3y dy minus sin 3y cos 3x dx is equal to 0. You should always write the given one initially. This will imply you sin 3x cos 3y dy to be is equal to sin 3y cos 3x dx. I'll try to take the y variables to LHS and x variables to RHS. Therefore, this will get reduced to cos 3y dy by sin 3y is equal to integral cos 3x dx by sin 3x. But if you observe carefully, derivative sin 3y is 3 cos 3y. Derivative sin 3x is 3 cos 3x. Therefore, instead of multiplying and dividing by 3 on either side, I'll multiply 3 on both sides. Anyway, 3 gets cancelled, I need it. Therefore, this is the form integral du by u is equal to integral dv by v, where my u is nothing but sin 3y, which is the denominator in the LHS. V is nothing but sin 3x, which is my denominator in RHS, which implies log u is equal to log v plus log c, which implies log u, I wrote it as y, log u is equal to log vc, log u is equal to log vc, which implies u is equal to vc, which implies sin 3y is equal to c sin 3x is the required, this is the required general solution. This is the required general solution. Let me just explain once again the whole lot. It is not at all a difficult process. Sin 3x cos 3y dy minus sin 3y cos 3x dx equal to 0. Take this to the other side. Bring sin 3y down. Bring sin 3x down. Derivative sin 3y is 3 cos 3y. Derivative sin 3x 3 cos 3x. Therefore, multiply 3 on both sides. Or multiply divided by 3 on both sides. 1 by 3 gets cancelled. Either way, both are correct. This is the form du by u, dv by v, where u is sin 3y, b is sin 3x. Integral du by u is log u. Integral dv by u is log v. Everywhere, if we have log, I'll take the constant of integration as log c. Therefore, log u is equal to log vc. This is u, not x. Therefore, don't cancel log, equate just the quantities. U is equal to vc, that is sin 3y equal to c sin 3x is the required general solution. It is not at all difficult to follow. It comes under variable separable method. I am able to separate the variables and then proceed. Therefore, it is called variable separable method. I am able to separate the variables. But remember carefully, I am supposed to add a constant c1 towards the LHS with respect to y in the place of y, another constant c2 in the place of x, and c2 minus c1 I make it as c. Therefore, in any problem of that type, we normally add constant of integration only with the variable x. X is considered to be the independent variable. Y is considered to be the dependent variable depending on x normally. When y is given in terms of x, we call it as y is the dependent variable depending on x. X is the independent variable. Next question goes like this. A bag contains 2n plus 1 coins, out of which n are two-headed coins. Both the sides are heads, that's the meaning. Remaining are normal coins, fair coins. One coin is selected at random and is tossed. The probability of getting a head is 23 by 31. If such a case arises, find n. This is the question. Just see. Just read the question if you want. This is the question. Okay, let me just see how we go about the answer here. Let E1 be the event of selecting a two-headed coin. Let E2 be the event of selecting a fair coin, in which one side is head, other side is tail. That's the meaning, fair coin. Let E be the event of getting a head when we toss a coin automatically. Okay, now P of E1. How many two-headed coins are there? N. Total number of coins, 2n plus 1. P of E2. How many fair coins are there? Other than n, there are n plus 1 fair coins. N plus 1 by 2n plus 1. Now P of E bar E1. We are selecting a two-headed coin and you are getting a head. You will always get a head. Therefore, it is a sure event. You will get it to be 1. P of E bar E2. Denominator occurs first in both the cases. You are getting a fair coin and you are getting a head. In any fair coin, it is n of h divided by n of h comma t. This is the application. That is why I get it to be 1 by 2. That's why I get it to be 1 by 2. Now, E1, E2 are mutually exclusive. Mutually exclusive and exhaustive. You can just, if it is a fair coin, it won't be a two-headed coin. If it is a two-headed coin, it won't be a fair coin. Therefore, they are mutually exclusive. Sum of probabilities n plus n plus 1, 2n plus 1 and 2n plus 1 is 1. Or their intersection is empty. The union is sample space. Either way you can say. Both are same. Now, P of E happens to be, condition given here is 23 by 31, which can be written as P of E1 into P of E bar E1 plus P of E2 into P of E bar E2 is equal to 23 by 31. This rule is called total probability theorem. This rule is called total probability theorem. It's just half of your application of a Bayes theorem. Now let me substitute the values. What do I get? N by 2n plus 1 into 1 plus I will get n plus 1 by 2n plus 1 into half is equal to 23 by 31. Now my LCM is 2 into 2n plus 1. Therefore 2n plus n plus 1 by this much is equal to 23 by 31. Therefore let me cross multiply. I end up with 62 plus 31 is equal to 4n plus 1 into 23. Let me just do only the simplification part here. Are you able to follow? 62n, sorry. (31) means 31, 3n, 93n, sorry. It is 93n, not 62. There are 3 n's there. 93n plus 31. 93n plus 31 is equal to 4n plus 2, sorry. 4n plus 2 into 23. Now let me just let me explain the whole part and simplification right over here, just here. Let E1 be the event of selecting a two-headed coin. Let E2 be the event of selecting a fair coin. Let E be the event of getting a head. P of E1, how many two-headed coins are there? N given in the question. N, total number of coins, 2n plus 1. How many fair coins are there? N plus 1. Remaining are fair coins. N plus 1 by 2n plus 1. P of E bar E1, you are having a two-headed coin and you are getting a head. You will definitely get a head. It's a sure event. 1. P of E bar E2, you are having a fair coin and you're getting a head. It's n of h divided by n of h comma t. It is half. E1, E2 are mutually excluding exhaustive. Therefore, you can apply total probability theorem. P of E is 23 by 31, that is given. Getting a head is probability is 23 by 31 given. Therefore, P of E1 into P of E bar E1 plus E2 into P of E bar E2 is 23 by 31. Therefore, n by 2n plus 1 into 1 plus n plus 1 by 2n plus 1 by 2 is equal to 23 by 31. 2 into 2n plus 1 is the LCM. 2n plus n plus 1 by 2 into 2n plus 1 is equal to 23 by 31. Therefore, cross multiply 31 into 3n, 93n plus 31 is equal to 4n plus 2 into 23. Let me simplify further here. I end up with 93n plus 31 is equal to 92n plus 46, which implies n equal to 15. Therefore, value of n happens to be 15. 93n plus 4 3s are 12, 8 plus 1 9, 92n plus 23 into 2 is 46. Therefore, n happens to be 15. Therefore, value of n happens to be 15 here. I'll just see the simplification here. 3n plus 31 is 93n plus 31 is equal to 23 into 4n, 92n plus 23 into 2, 46. 93n minus 92n is n. 46 minus 31 is 15. Therefore, value of n happens to be 15. It's just application of total probability theorem. It's half of your Bayes theorem. Half of your Bayes theorem. I hope it's clear to you. It's not at all difficult problem. If the value 23 by 31 is given, another value is given in this place, solve accordingly for n. It's not a difficult task. Let me check for the calculation part. Otherwise, if there is no error, I'll upload as it is. If there is any error, I'll add up as usual. Thank you, students, for patient watching.